Hey, hello everyone. Good morning. In today's session, we'll understand about Kubernetes RBAC, basically role-based access control. So, what is this RBAC? As a Kubernetes administrator, when we are managing the Kubernetes cluster and the Kubernetes cluster will be used by so many users. Users means not end users. Here I am talking about the Kubernetes users like a developers, DevOps guys, or any other CI/CD applications or a process. Right? Sometimes some applications or a programs also need access to the Kubernetes clusters in order to create or update or delete some Kubernetes resources within the cluster. So for any particular user or for any particular group of users, or for any applications or programs, how we can give access to the Kubernetes cluster, we'll try to understand in today's session. So as you guys already know, if your application team is trying to build and deploy applications as a containers, right? Containerized application. So there is a problem with the containers. If something goes wrong with that container, or if something goes wrong with the machine on which we hosted the containers and applications running in the containers are not available or accessible. So we need someone who can orchestrate this container, or we need someone who can manage these containers. That is where we have a container orchestration tools such as Docker Swarm, Kubernetes, OpenShift, Nomad, these type of container orchestration or container management tools. These container orchestration tools or container management tools will create and manage the containers in a cluster. So you can have a single node clusters also. We can have a multi-node clusters. So basically, cluster is nothing but it's a group of one or more machines. These container orchestration tools will schedule the containers on that cluster nodes, and they will try to replicate the containers. If something goes wrong with that container, we can scale out the containers based on the demand or a load, and we can load balance those containers. That is what any container orchestration tool actually does. So this Kubernetes is also one container orchestration tool. Using Kubernetes, we can schedule and manage the containers. But here, we cannot directly create and manage the containers in Kubernetes. Containers will be created and managed using something called pods. Again, the pods also, we should not directly create a pods in Kubernetes. You have to create and manage the pods and its life cycle using some other Kubernetes resources like replication controller, replica set, deployments, daemon sets, stateful sets. And again, in order to communicate with that pods that is deployed in the cluster, we will create a services with various types like a cluster IP service, node port service, load balancer service, and again we will create ingress rules, network policies. Suppose for that applications or a containers deployed in a cluster, you wanted to you know pass some kind of a configurations to the containers from outside of the containers. Then we will use config maps, and we can create a data using config maps like simple key values data or a file like keys. If required, we can refer that config maps in a containers command line arguments or maybe environment variables. If required, we can mount the config maps into pods containers as a values. You can use secrets for sensitive data. And similarly, if your applications are a stateful applications, in order to maintain the state or a data generated and used by your applications, you can go and use persistent volume claims as a values, and the persistent volume claims will get the values either dynamically provisioned using storage class, either manually created by admin. Like this, there are so many Kubernetes resources. But again, it doesn't mean like everyone will have access to all the Kubernetes resources. It is not like anyone can go and create a value, anyone go and can delete the value, or it is not like anyone can go and create a namespaces and or create or update, delete the resource quotas. It is not like that. we need to control access to the Kubernetes resources based on the particular person roles and responsibility. So as of now, you guys, as of now, we have the cluster. As of now, since it's a learning or a training, everyone has their own Kubernetes cluster. You have your own Kubernetes cluster in which you are practicing. I have my own Kubernetes cluster where I am trying to explain the concepts to you guys. But when we are working for any applications or projects, it is not like every developer or every DevOps guy or every one have their own cluster. So here we will have a Kubernetes cluster per project or per environment like that. Let's say you are working for one application or project. In for that application or a project, for dev environment, you may have one cluster. For QA environment, you may have another cluster. Prod environment, you may have another cluster. And again, that cluster that can be like a dev cluster, prod cluster, QA cluster will be used by so many peoples like application teams, DevOps teams, CI/CD monitoring teams, database teams. In case the databases has to be deployed in that Kubernetes cluster as a pods again. So various teams need access to the cluster, but which doesn't mean all the teams and all the users like developers, database admins. Not everyone will have a full permissions or admin permissions in the cluster. So we need to control. You need to give access to the cluster. At the same time, you need to control what that particular team or that particular user can perform within the cluster on that Kubernetes resources. That is where this RBAC comes into the picture. That is where this RBAC, role-based access control. Right? So let me try to explain. As of now, as I already said in the previous sessions in the Kubernetes architecture, whenever we are trying to communicate, whenever we are trying to communicate with Kubernetes cluster for creating, updating, deleting the resources, so first request goes to the API server. The API server, before processing that request, that can be creating a namespace, deleting a namespace, or that can be creating a pod or a deleting a pod. So before any I mean to say any request goes to the API server, before performing that action that can be creating something, deleting something, updating something, or getting something from the cluster, the API server will authenticate the request. And once authentication is successful, then it is going to authorize the request. If authentication and authorization if authentication and authorization is successful, then only the API server will perform that action what you are trying to perform within the cluster. So as of now, like we have everyone has their own clusters, and we used admin credentials. Suppose initially we started using a self-managed Kubernetes cluster. That's when we initiated the self-managed Kubernetes cluster. There was an admin user, and we were using admin credentials like access, like certificates. Kubernetes itself has generated the certificates, and that certificates was signed by Kubernetes, right? So we are presenting that certificates to the Kubernetes, that is generated and signed by Kubernetes. So using that certificates, authentication is happening. At the same time, for that admin credentials, that admin certificates, there is a full permissions in Kubernetes. That's why we are able to create anything, we are able to update anything, delete anything. And recently, we started using a EKS cluster. EKS with auto mode. In this EKS cluster also, like as a whatever AWS user, this EKS is internally integrated with IAM already for authentication, right? So as a whatever AWS user, we have created a EKS cluster, and by default that as a which user you created a EKS cluster, so by default that user will have a full permissions in EKS clusters, and already EKS is integrated with IAM. So when we configured the kubectl and the kubeconfig file, so we have used that that AWS user access key and secret key, right? So that AWS user can be again developer, DevOps guy, whoever created the cluster, who created that cluster. Basically, developers will not create the clusters, only DevOps or admins, right? So they have access to the cluster, but full permission. Later they can grant access to the other people like that development team, testing team, like that. So already e-case is integrated with IAM for authentication, and whatever user created the e-case cluster, that the first user who created the cluster, they will have full permissions in Kubernetes also, and the first user who created that cluster, that user can grant access to other users. Other users, they can grant admin access to the other users, or maybe read only access to the other users particular resources, like that. So as of now, let's say we have a different requirements, right? But if you don't know what is Kubernetes architecture, what is API server, what is scheduler, this we have already discussed in the regular sessions also, and there is a dedicated video in our YouTube channel. We have a we have created and uploaded one YouTube, one video on this YouTube channel. It is all about the Kubernetes, right, architecture. So if you know the Kubernetes architecture and how Kubernetes will create and manage those resources, right, everything becomes easy. Here in our YouTube channel, there is a video. If you there Here I have already explained what is Kubernetes, what is controller, what is masters, workers, how we can communicate with that. There is a detailed video in this channel, right? You guys can go through, but in anyhow we have discussed in our regular sessions. Now let's understand this RBAC concept. Let's understand this RBAC concept, how we can control access. So Kubernetes role-based access control. When any request goes to the API server, understand again whether it is a self-managed Kubernetes cluster using Kubedium, that self-managed Kubernetes cluster you have configured in on-premise data centers, or maybe cloud like AWS, Azure, GCP self-managed. Otherwise, even it is a local Kubernetes cluster, single node Kubernetes cluster also, the concept is same. Whether it's a fully managed Kubernetes cluster, self-managed Kubernetes clusters, and single node Kubernetes clusters, that doesn't matter. When any request goes to the API server, so first it needs to be authenticated. What type of request? How request will go to API server? Suppose you wanted to create a namespace. Suppose you wanted to delete a namespace. Suppose you wanted to create a deployment, or you wanted to update the deployment. Suppose you wanted to create a resource quota, or you wanted to update the resource quota. You wanted to create a config map, secret, these type of requests. When any request goes to the API server, first the API server will authenticate the requester to make sure that requester is known, to the system. And again, this Kubernetes supports various types of authentication, right? So we can't create a users within Kubernetes. The users will exist outside of the Kubernetes clusters. That users can be part of your organization LDAP or AD, Active Directory. Otherwise, if you are integrated your let's say you are already using cloud, and your cloud is integrated with the LDAP or Active Directories, or maybe within a cloud like AWS, that can be a IAM user. That users exist outside of the Kubernetes cluster. You can't create a user entities. You can't create a user entities within the Kubernetes cluster. The users can be part of LDAP, or that users can be part of Azure Active Directory, or that users can be cloud like IAM users in AWS, like that. So the users will be part of outside of the cluster, but this API server can be integrated with that external identity providers. This API server can be integrated with the external identity providers such as LDAP or Active Directory, or maybe cloud security like IAM in AWS, like that. So if it is already, if that API server is integrated with that, so any request goes to the API server, whatever credentials you are presenting to the API server will internally contact that identity provider, and it will verify whether the given credentials is proper, whether given user exists as part of that identity, right? So if that user exists and the credentials is valid, then authentication successful. And once the authentication is done, the next thing is authorization. That authorization or permissions will be evaluated within the Kubernetes clusters. The Kubernetes permissions are there or not, it will evaluate it. If authentication is failed or authorization is failed, then it will not proceed further, right? So when any request goes to the API server, first it needs to be authenticated to make sure that the requester is known to the system before it is authorized, to make sure the requester is allowed to perform that action. Like that action can be getting a details of nodes, or creating a namespace or updating a namespace. Those actions, if there is a permissions, then only the API server will allow. So using RBAC is a way, RBAC is a way to define which users can do what within a Kubernetes cluster. Which users can do what within a Kubernetes cluster. You can control that by creating RBAC policies, RBAC rules in Kubernetes. So this role-based access control is a way of granting users to the access. This RBAC is a way of granting users a granular level access to the Kubernetes resources. So using RBAC, you can grant a users a granular level access to the Kubernetes resources. What do you mean by Kubernetes resources? What are Kubernetes resources? That Kubernetes resources can be pod, the Kubernetes resource can be namespace, that Kubernetes resource can be network policy, ingress, all these API resources. Let me tell you. All these API resources. Everything is a resource here. Right? So all these are like a Kubernetes resources. So using RBAC, you can create a permissions to the, you can grant permissions to the users on these resources, like a create, update, delete permissions on pod, create, update, delete permissions on these deployments or daemon sets or namespaces, like that. So using RBAC, you can give permissions to the Kubernetes resources for the Kubernetes users. So RBAC is a way of granting users granular level access to the Kubernetes resources. RBAC is a security design that will restrict access to the Kubernetes users based on the role that user is holding, based on the role that user is holding, right? So here, right, you can use this RBAC, you can use this RBAC to grant access to the Kubernetes users. Permissions. So let me take this is very common use case. Let me take this is very common use case. Let's say you have a Kubernetes cluster. You are working as a Kubernetes admin, as a DevOps engineer or a senior DevOps engineer, or maybe DevOps lead or architect. Suppose you are working on Kubernetes for some time. You may have a scenario. You may have a scenario where you have to give some users, some Kubernetes users, limited access to your cluster, right? For example, you may want a user, let's say Balaji itself is a developer. Let's say he's from some development team, and he wanted to have a access to the Kubernetes, but only limited access. So let's say, for example, you may want a user like Balaji from development to have a access to only some Kubernetes resources, only some Kubernetes resources that are in the some particular namespace, again, that are in a particular namespace, or maybe that are in a all namespaces, or that are in a particular namespace, but nothing else. You should have a permission. To achieve this type of role based access, we can use the concept of authentication and authorization in Kubernetes. Let's say Balaji is from development team, he is working for one application. Is it recommended to have Balaji with full permissions? Let's say, is it recommended to give Balaji like namespace permissions for creating, deleting, let's say updating resource quotas, deleting resource quotas, or maybe updating or deleting storage classes or volumes or some secrets in Kubernetes, like that? No. So we need to restrict. We need to restrict these type of things, right? So we need to restrict these type of things. To achieve this type of role-based access in Kubernetes, we can use the concept of authentication and authorization. But before we get into insights of how we can do this, let's understand how many types of users, maybe what type of users will be there and who need access to the Kubernetes cluster. Broadly, there are three kinds of users that need access to the Kubernetes clusters. Broadly, there are three types of users who need access to the Kubernetes clusters. So users means here developers or admins or DevOps guys like that. So here broadly there are three kinds of users. Broadly there are three kinds of users that need access to the Kubernetes clusters. That developers or admins, they need access to the Kubernetes cluster for doing developmental tasks or administrative tasks. So these developers or admins need access to the Kubernetes clusters. These users are responsible for doing administrative tasks or developmental tasks on the cluster. Administrative task means configuring a storage class, creating a resource quota, or updating the resource quota, and creating a namespaces and giving permissions to that namespace for some other people, some other developers, like scaling the cluster, granting access to the cluster, configuring a storage classes to provide the storage in the cluster, creating namespaces and giving again permissions to that namespace. These are like administrative tasks. So here developers or administrators need access to the Kubernetes cluster for doing administrative tasks. And developmental tasks means that application team wanted to deploy their applications. They may need access to create a deployments, update the deployments, or creating a config maps and creating a services, ingress rules, network policies, like that developmental task, right? These guys need access, developers and admins. So users that are responsible for doing administrative or a developmental tasks on the cluster, this includes operations like upgrading the cluster, creating a resources or workloads like the pods, deployments, etc. on the cluster. So these guys need access to the cluster. And one more type of users, I can say end users. I do We can't say these end users are like a Kubernetes users. End users are different. So end users is not like a Kubernetes users, but end users will access the applications deployed on the cluster. But for end users, you are not going to give any permissions to the cluster, but end users will just access the applications deployed on the cluster. So there is a end users, end customers. This end users is going to access the applications deployed on the cluster. But how they can access the applications deployed on the cluster? That applications is deployed by this development team manually or maybe via CI/CD. We might have created a deployment services, ingress rules, config maps, and we deployed that in the cluster. But how end users can access the applications deployed on the cluster? For end users, you don't need to give access to the Kubernetes cluster. End users will just access the applications deployed on a cluster. So how they can access? We have already discussed as part of previous sessions, if you guys attended. So how end users can access the applications deployed in a cluster? We are not going to give access to the cluster. They will just access the applications deployed in the cluster. Understand? So how they can access the applications deployed in a cluster, that end users? So via ingress controllers, that external, via that all the external traffic, the end users from outside, external networks, they will access the applications deployed in a cluster via that ingress controller load balancers. Via that ingress controller load balancer, request will come to the ingress controller pods, and we may have a created ingress rules. According to the rules, that ingress pods will route the traffic to the services to the appropriate pods, like that. So that they will just access the applications deployed on the cluster. But we no need to give access to the Kubernetes cluster, understand, right? But maybe that application will have some access restrictions. The applications deployed on the cluster may have some access restrictions. Just to give an example, you have hosted some kind of a banking application, or you might have hosted some kind of any application. Maybe in that application also there will be access restrictions based on the user. Again, suppose, just to give an example, you take any banking application. I am talking about internal banking application. In the banks also we have a clerk, assistant manager, director, regional manager, like that. So let's say there is a hierarchy in the that business, right? So again, whatever operations or whatever tasks a manager can do, the clerk cannot perform the same type of tasks in that bank. Let's say there is an application hosted in that clusters like that. That application also may have their own access restrictions that we don't need to take care. So access restrictions in the applications deployed in the cluster, who will take care? Again, application team, the development team itself will have some kind of a mechanism based on the person who is accessing that application, that may have access to that application resources. Here I'm not talking about Kubernetes. So users will access the applications deployed on the cluster. Maybe access restrictions for those users, end users, may have in the application that will be managed by application team itself. So for example, you are running one web application on a Kubernetes cluster. That application will have its own security mechanism to prevent unauthorized access. That will be taken care by application team. But here I am talking about permissions to the Kubernetes. So developers, DevOps guys or admins need access to the Kubernetes cluster for performing administrative or developmental tasks. So we need to give access to these developers or admins to the cluster. But end users will just access the applications deployed on the cluster. Here we have one more type of users. Applications are a bots. Applications are a bots. Means as I said, some process. Let's say instead of you are manually deploying the application to the Kubernetes cluster, maybe instead of manually deploying, you can have some kind of a process like a CI/CD process. Let's say you have a Jenkins. Jenkins is not a user. Jenkins is a software or an application. Suppose Jenkins requires access to the Kubernetes for creating a deployments, creating a config maps like that. Or maybe not only Jenkins. Let's say we have already deployed metric server. Metric server is one application, one software. That metric server also requires permissions to the Kubernetes resources to get the details like node metrics, pod metrics. It has to get so that metric server also need access to the Kubernetes resources. Not only that, suppose we have deployed something like storage classes, that provisioners, dynamic values, right? That also requires access to the values because that persistent volume object will be created dynamically. Suppose you are using Carpenter or a cluster autoscaler to scale in, scale out the cluster based on pods pending state. So that Carpenter or a cluster autoscaler also need access to the Kubernetes to check whether how many pods are there, how many nodes are there, is there any pods in a pending state, that pod permissions, node permissions. So for these type of applications or a bots need access to the Kubernetes cluster. Here there is a possibility that other applications need access to the Kubernetes cluster or Kubernetes APIs, basically that, right? So typically to talk to the other resources in the cluster, Kubernetes can facilitate using something called service account. So service account can be created within the cluster. You can create one service account in that cluster, but if it is a users, it is not within the Kubernetes. That users can be outside, like developers, DevOps guys. This can be LDAP, this can be LDAP, or this can be Azure Active Directory, or this can be IAM, like that. So this API server can contact this external identity provider for authentication in case of users like developers, DevOps guys, like that. If it is a application or a bot need access, right? Not humans, not human entities, process. In that case, you can create a service account within the cluster. For this service account, you can give permissions to the Kubernetes resources. You can create a role or a cluster role where you can give Kubernetes permissions. Then you can bind this role with this service account using cluster role binding, like that. Then if some process or application is using this service account, so request goes to API server, and this process is going to communicate with that cluster by giving a service account name. So this API server will check, okay, do we have a service account with that name in the cluster? Okay, if that service account is there, is that service account has binded with which role, and that role has which permissions in Kubernetes. According to that, it will allow that applications are a bots, right? So this there is a possibility that the other applications or programs or bots need access to the Kubernetes clusters or Kubernetes resources. You can facilitate this using service account. So you can create a service account within the cluster, and for that service account, again, you can bind some role. In that role, you can use some kind of a Kubernetes permissions. According to the role that is attached to that service account, and that application or a program that is using that service account to communicate with the cluster, they will have a permissions like that. So that is how it will work. But within Kubernetes, you can't create a users. There is no Kubernetes object that will represent the user, like a developer, Balaji, Rutvik, Shishir, or maybe group, like some groups like that. These users and groups can exist outside of the Kubernetes clusters. So here there is a detailed information about authentication and authorization in Kubernetes. Authentication and authorization in Kubernetes. This is official website. Here you can see authenticating, authorization. First authentication, after that only authorization. If authentication itself is failed, there is no way of authorization. Now let me open this Kubernetes docs, and here also high level you can see. In Kubernetes, authentication is the process of verifying user's identity, while authorization determines what actions the verified user is allowed to perform. So both happens sequentially. First authentication will happen, then authorization will happen. So when any request goes to the API server via Kubernetes CLI, or maybe via Kubernetes APIs, or maybe you have a Kubernetes console. If required, you can set up a Kubernetes console also, but that console is only used for a read-only purpose like that. When request goes to the API server via Kubernetes console, or maybe Kubernetes CLIs or API, so when request goes to the API server, before that allowing first authentication verify who the user, who are you, first of all. Suppose you are asking me to perform something, first I should know who are you. So first that who are you, like it is going to verify the user's identity or service account. So user or a service account is for applications or programs or a bots, users like developer, DevOps guy, or any other database admins like that. But Kubernetes don't have an internal user database for human users. So within Kubernetes, you can't create a users. Like in AWS, you have created a user. Like in Jenkins, also Jenkins users you have created. In Nexus also you have created a Nexus users. In SonarQube, we have created a users in SonarQube. That internal database we don't have for users in Kubernetes. These users exist outside of the cluster, external mechanism, right? So here Kubernetes don't have an internal user database for human users. It will rely on external mechanisms and configurations to validate the credentials presented with API request. So here again, common authentication methods, right? Even though you can't create a user, but there is one approach called certificate. You can generate the certificates. There are so many ways we can authenticate with Kubernetes, right? So one is a certificate based authentication, token based authentication, like that. So certificate based authentication. Suppose even though you can't create a user, at least you can generate some kind of a certificates to the user. So this is what in the self-managed Kubernetes cluster, initially we have generated a Kubernetes, we have created a self-managed Kubernetes cluster, but we have not integrated that Kubernetes with external identity providers like LDAP or Active Directory or AWS IAM like that. Right? So in that case also, you can generate a certificates, and these certificates can be get signed with the Kubernetes itself. And if that users are presenting that certificates also, with that certificate generated by Kubernetes, authentication will be done within Kubernetes. Otherwise, if it is not certificate based authentication, if it is like a token based authentication, or this external identity providers using LDAP or Active Directory, this type of things also it can done. So there is something called authentication, right? All Kubernetes users have a two types of users, but here they're not talking about end users. Here they're not talking about end users because end users don't need permissions to the Kubernetes clusters. End users will just access the application. But here they're saying only two types of users. One is the service accounts, another one is normal users. These normal users like a developers, DevOps guys like that. But here they are not talking about the end customers. Anyhow, end customers don't need access to the cluster. They will just access the application. So all Kubernetes clusters will have a two categories of users: service accounts managed by Kubernetes itself and normal users. It is assumed that cluster independent service. It is assumed that cluster independent service manages the normal users, right? Maybe independently it will manage. Maybe we can generate the keys as a Kubernetes admin. You can generate the keys and you can give access to the, you can generate the certificates. That private keys are like a certificates, and you can get it signed with the that Kubernetes. And if the certificates is given to Balaji by Kubernetes admin, he can present that certificate via kubeconfig file to the cluster, so that authentication will be done. Otherwise, external identity. But these certificates will be working only for one or two users. But if you have hundreds of users in your company, like a development team, DevOps team, this is not easy to generate the keys or certificates for every user and again distribute these keys to those users and again like that for authentication. So most of the time we will have an external identity provider. This Kubernetes can be integrated with external identity provider, so that request will go to API server. The API server can contact that external identity where it will verify that the identities are there or not, right? But what here they're saying, Kubernetes don't have any objects, Kubernetes objects to represent normal users. Normal users cannot be added to the cluster using Kubernetes APIs, right? But even though normal user cannot be added to the Kubernetes cluster using API calls, any user that present a valid certificates generated and given by Kubernetes, if they are presenting that certificates, and if that user presenting the certificates, and if this user has a permissions given using RBAC, then they can access also. That's what they're saying here. So here there are so many ways. Like when we are configuring a Kubernetes cluster itself, when we are configuring a Kubernetes cluster itself, right, you can integrate with external identity provider. You can integrate with external identity provider like LDAP or Azure AD using this OpenID, using this OpenID Connect or OpenID protocol, like SAML or OpenID protocols. There are some protocols like this. So when we are configuring a Kubernetes cluster, you can integrate with external identity provider. When we are configuring a Kubernetes cluster, you can when we are configuring a Kubernetes cluster, that API server is also one application, one process, right? For that API servers, you can give this identity provider details. So if any request goes to API server, to which identity provider it has to contact, like using OpenID or a SAML, you can connect the external identities. So using these arguments, you can integrate API server. These are like arguments to the API server itself. So if you add these arguments with the given URLs, external identity URLs like LDAP or Azure Active Directory or something like that, then the API server will contact that external identity. Suppose if I am using EKS cluster or AKS cluster or GKE cluster, already it is integrated with IAM. Suppose if request goes to that EKS cluster API server, then it is internally going to contact IAM also for authentication. If IAM is already integrated with external identity provider, maybe that IAM will contact external identity. But if you are using on-premise or a self-managed Kubernetes clusters, maybe you have your own LDAP or Azure Active Directory. When we are configuring the cluster, you can give these identity provider details. You can connect those two using these type of arguments again. But this is one-time activity. Suppose you joined any project. Suppose you joined any project or an application. Suppose you have joined any project or an application in the day zero, first day you have joined initially. That time maybe you may need to create a cluster, you may need to set up these type of things. But again, these type of things will be taken care by most of the time senior people who are already having enough experience in all these concepts. Maybe for freshers or less experienced people, these type of things may not be allocated. But I am not considering your experience level. Here I am trying to explain at least all the concepts. If you know the concepts, then you can go for an implementation. But without knowing the concept, you can't do any implementation, right? So you can work with that identity center team, you can get those details and you can pass those details here, so that this API server can be integrated with external identity. Now we are using EKS cluster. EKS is already integrated with the IAM, AWS IAM, right? Suppose you are using AKS, GKE also, they have their own security, right? So it will contact there for authentication. Like now, that is how authentication will happen. Once that authentication is done, permissions, but permissions to the Kubernetes resources you can define within Kubernetes. How you can define permissions to those verified users, authenticated users? That is where we have these Kubernetes objects. That is where we have these Kubernetes objects like role, cluster role binding, like that. These are also like we have pod, deployment, service, config map, like that. So these are also like Kubernetes objects only. Let me show here. Let me show here. kubectl API resources. Here I am talking about these four objects. These four objects to give the permissions to the users or a service accounts. So service account can be created within the cluster. Suppose any application or a program need access to the Kubernetes resource, there is something called service account. So you can see that service account can be created in the cluster, and for that service account you can grant the permissions using this RBAC, role based access control. These are the objects, role and role binding, or a cluster role and cluster role binding. Using this you can give permissions to the service accounts within the created and managed within the cluster. Also you can give the permissions to that service accounts, or maybe users that is independent from the clusters that exist outside of the cluster, right? But for that users or a service accounts, you can give permissions to the Kubernetes resources using these objects. So here you can see service account. We have already used this service account when we deployed metric server, when we deployed a lot of other things like ingress controllers, like that. Also there was a service account. That parts are applications using that service accounts, or programs using that service accounts to get permissions to the Kubernetes. So here you can see there is a concept of service account also, somewhere you should see that. Otherwise you can use grep also, because if there are so many service accounts, so these service accounts can be created within the cluster. You can see kubectl get service accounts, SCA in the short form, full form service accounts. Again, this is like a namespace resource. In whatever namespace you are creating a service account, but permissions you can give for all the namespaces in the cluster. All the namespaces in the cluster, again, all permissions in all namespaces, or few permissions in few namespaces, like that. Also, we will discuss about that RBAC. But for you can give service accounts also in the short form SCA, full form service account. So this is service accounts, right? In all namespaces also, if you wanted to see service accounts like this, we have a service accounts. You have a service accounts. So you can see we have some service accounts. Via the service accounts, applications or programs will get access. You can see there is a service account called metric server. kubectl describe. This metric server is one service account, and This service account is binded with some permissions using that role or a role binding, or using cluster role binding. Using that, we have given some permissions to the service account. The service accounts are again, these service accounts are again used by applications or a program, so that they will get access to that Kubernetes resources as per the as per the permissions attached to the service account using that role binding like that. So this is one service account, right? This service account is internally attached with some, we have something called role binding, cluster role binding like that. So we have roles, right? Maybe let's say here maybe instead of normal role, let's see cluster role. So maybe let's see here, you may have something like this metric server role, right? Metric server. Using this again, this is role, cluster role. Let's say cluster role. This is the name of the role. I wanted to see in a YML format. But again, in order to create these roles, cluster roles, in order to see the roles, update the roles, or delete the roles, and bind that roles, again, who can do that? Again, who has a permissions on this object also? Who has the permissions on this object also? Who has a permissions on this object? They can only do that. Suppose now we are interacting with API server. If these guys has a whom you are interacting with that API server, if that person don't have a permissions on this is also on Kubernetes object. If these guys don't have a permissions, that again Kubernetes will not allow. Now, as a which user I am interacting with Kubernetes, as whatever user I have created a EKS cluster, as a same user I am interacting, and that user by default has a full permissions in Kubernetes. That is also granted via role binding only. Now these are like a permissions like a pods, nodes, namespaces. These permissions given via this role, and this role and that account, service account, is linked together using something called binding. But anyhow, I will discuss that. Using service accounts, you can grant access to the applications or a programs or a bots within the cluster. But using you can create a service accounts within the cluster, but you can't create a user identities. You can't create, that will be outside of the cluster. But using this role binding, cluster role binding objects, you can control and manage the access to the Kubernetes. Now let's understand what is role. So Kubernetes role. Role defines what can be done to the Kubernetes resources. Role defines what can be done to the Kubernetes resources. Role contains one or more rules. Role contains one or more rules that represent set of permissions on a Kubernetes resources. So role defines what can be done to the Kubernetes resources. That Kubernetes resource can be pod, deployment, namespace, resource quota, config map, ingress, network policy, secret, like that. So role defines what can be done to the Kubernetes resources. Role contains one or more rules. Role contains one or more rules that represents a set of permissions. That represents a set of permission. Roles are namespaced. Roles are namespaced, meaning role work within a constraints of a namespace. What does it mean? Roles are namespaced, meaning role will work within the constraints of a namespace. Suppose using role, I am giving some permissions to the Kubernetes resources like a pods, deployments, config map, secrets, like that. If I am creating that role in namespace A, suppose using role, I am giving permissions to some Kubernetes resources like pods, deployments, config map, secrets, like that. And that role I am creating namespace A. And this role I will attach to some user. Is that user will be able to access the resources in other namespace? Suppose using role, I have given a permissions to the some Kubernetes resources, and that role is created in namespace A. Is that user or a service account attached with this role? Will they have that permissions on other namespaces if it is granted via role? No. That is what the meaning of a namespaced. So role defines what can be done to the Kubernetes resources. Role contains one or more rules. Role contains one or more rules that represent set of permissions. Roles are namespaced, meaning role will work within the constraints of a namespace. Suppose while creating a role, if I don't mention namespace name also, it will be created. It will be created in a default namespace. Default namespace. But if you just create a role, you are not binding or assigning that role to the user or a group of users or a service account. Again, is that permissions will be inherited by any user, any groups, any service accounts if you just create a role without binding that role to service account or a group or a user? No. So after creating a role, you have to assign it to a user or a group of users or maybe service account by using role binding. Using role binding, you are binding that permissions to the particular group or particular user or particular service account, right? Suppose, just to give an example, this role is also one Kubernetes resource. Kind role, this is the API version, metadata, name of the role, in which namespace the role has to be created. But using role, you are defining a rules like this. For pods, these permissions like that, or maybe for not only just pods, suppose deployments, some permissions, config map some permissions, secret some permissions like that. So you can create a role, and each role can have a set of rules. In this, again, three sections: API groups, resources, verbs. So resources means Kubernetes resource. That can be pods, that can be deployments, that can be config maps, that can be secrets, that can be ingress rules, network policies. Even this resource can be a role also. Suppose someone need permissions to create a role, someone need permissions to update the role. In that case, with the person who don't have a permissions on that role or role binding or a cluster role binding, do you think they will be able to create these type of roles? Do you think they will be able to update these roles, delete these roles again? No. So this role is also on Kubernetes resource. So in order for creating a role, and role binding, in order for creating a cluster role and cluster role binding, again that person should have the permissions on that. Without that, again, it will not allow them to create, update, delete like that, right? So basically, who will have a permissions to create these type of roles, cluster roles, admin, I mean say bindings? The admins, Kubernetes admins. That admin can be you or me, working as a DevOps engineer for that application or a project. You are responsible for creating. Suppose there might be so many DevOps people again, but do you think there will be entry level DevOps engineers, right? Freshers joined as a DevOps engineers, or maybe entry level. Suppose if it is a critical cluster and production cluster, do you think for DevOps engineers also, for entry level people, do you think they will give these type of things, full permissions in that cluster again? No, right? So the person who are already a SME, subject matter expert, right? Subject matter experts like seniors, leads, architects, they will have these type of things also. But maybe in lower clusters, even lower clusters, maybe permissions will be given for junior DevOps engineers also. But this is how it works. Now you can create a role like this with permissions. So here, very simple. This is nothing complicated, but you have to break down the things. So you have to break down the things, right? So that is where I am helping you guys to break down the things. If you know the concepts, everything becomes simple. But without understanding the concepts, if you go and directly jump into something, even though there is so much content available publicly also, you don't understand what exactly this, why, how it works, where you can use. That is where an instructor or guide, instructor me is required here. So just to give an example, here it is very simple. You are creating a role. This is the API version of the role. This is like in this namespace, this is like a name of the role. You can give anything, but here we have a rules. This is completely one rule. In this, you have a API groups, resources, verbs. Resources means this is your Kubernetes resources that can be pods, all these things. kubectl API resources. kubectl API resource. So here, all these things, I mean to say here, pods, nodes, namespaces, deployment services, like that. These. Suppose I wanted to give permissions to the services, let's say services. So this is a resource. So here resource pods. If required, multiple resources also I can give. For pods and services, verbs means permissions. So here we have some permissions: crud, create, read, update, delete, like that. Get permissions, watch permissions, list permissions, like that. But all are read only, all are read only, right? So but here we don't have a create permission, update permission, delete permission. Suppose this is the role. This role I am attaching to some user like Balaji using role binding. Using role binding, I'm attaching this role. I'm attaching this role to the user called Balaji. So Balaji will get access to only parts and services, and again only this permission. Only these permissions for parts and services. Understand what I'm saying? But now, is Balaji will be able to create a pod, delete a pod? Is Balaji will be able to create a service, delete the service, update the service only with these permissions on that resources? No. And again, we are giving only this permission. But again, is Balaji will be able to get deployments, get read only also? Only these, only for these resources I have given this permission. Is Balaji will be able to get the deployment services? I mean, say deployments, config maps, secrets, and other resources? No, because only for these resources, these permissions, like that. So understand what do you mean by these resources here? What do you mean by this verbs here first, before I explain about this API groups? Now, every resource belongs to some API group. So every resource belongs to some API group. So this parts and services belongs to V1. Suppose if it is a deployments, it is going to belongs to app slash V1. Suppose if it is you can see this API group. So these things you can consider as a core API groups, like a pods, replication controller, services, like that. So these belongs to this API version. You can consider this as a core API group. Core API group. Suppose if you see these resources, like I meant say daemon sets, deployments, replica set, they belongs to this API group. But here, when we are using RBAC, here API group, not version. You should not mention like this V1. It is, you should not mention like V1. If these resources belongs to this V1, you can just leave this group as empty. Empty. This considered as a core APIs. Core API. Core API means a V1. V1 empty. Suppose you need to give permissions to the deployments, daemon sets, but here you can't do that by mentioning API group empty, because this deployments belongs to this group. So in that case, what you can do, maybe you can mention like this one more rule. One more rule. Here you can say, you should not say app slash V1. You should not say app slash V1, just a group, right? Apps. So like deployments, deployments, like this. You have to give like this. For deployments, you can give. but only deployment. Suppose you need to give for stateful sets, stateful sets, daemon sets also. Can I give comma separated also here itself? Because that also belongs to this group only. Can I give something like this? Stateful sets also these permissions, comma, and daemon sets these permissions like that also, yes. But let's say here, if required, you can give more like a create, update if required, and delete like that. Create, update, delete like that. You have giving permissions, let's say. But understand one more thing. Suppose for deployments, you want to give create, update, delete permissions. Stateful sets also you wanted to create, update, delete. But for daemon sets, you don't want to give delete permissions. In that case, can I separate this into one more rule also if required, like this? Here I will not add this. Here only this daemon sets without delete permissions. Understand how you need to frame your rules if you are an admin based on the requirement. Now, what does it mean? For deployment stateful sets, these permissions. This belongs to this API group. For daemon sets, these permissions. That is also belongs to this API group. Similarly, suppose you wanted to give permissions to, let's say, ingress rules. Suppose that application team has to create an ingress rule. So that ingress rule belongs to which API group? That ingress, that Kubernetes ingress. So here networking like this. But you should not give completely like this. Just a group networking.kubernetes.io, and the resource is this one, not short form. This form you have to give ingress, and these permissions like this. Based on your requirement, you can create a rules like this with for whatever resources that belongs to whatever API group, if required. Let's say sometimes you can give something like this also, like let's say star API group star, resources also star, and verbs also star. What does it mean in this case? What does it mean in this case? All the API groups, all the resources, all the permission. But you are using a role. And this role is created in default namespace. Even though you have told all, but these permissions only for the resources in this namespace, in whatever namespace you are creating. But in other namespaces, do you think they have a permissions? Again, if you do like this also, no. Right? So this is how you can create a role with all permissions or only limited permissions, like this also you can give. But again, this role will work only for namespace level resource. Suppose for cluster level resources, like a namespaces, you wanted to give read permissions. For nodes also you wanted to give read permissions. For persistent volumes also you wanted to give read permissions. For cluster level resources, not a namespace level resources, for cluster level resources, you can't use a role. For cluster level resources, for nodes, namespaces also, you wanted to give read only permissions, maybe that you can't do using role. That is where you can use cluster role. I will come to that point. First of all, is everyone clear what is role exactly and how to define the rules in this role? Now, in that roles, in that rules, you have a API group, resources, verbs like that. And there is something called role binding. What is this role binding? Role binding is used for granting a permissions to the subject. Sir, what is this subject? Role binding is used for granting a permissions to the subject. What is that subject? That subject can be users, or that subject can be groups, or that subject can be a service account. Role binding is used for granting a permissions to the subject. The role binding is going to hold a list of users or a groups or a service accounts referencing to a role being granted. And this role and role bindings are used in a namespace scope, right? Role binding can refer any role in that namespace. Role binding can reference any role that is created in that namespace, right? But after you create the binding, you cannot change the role that is referencing in that binding. If you wanted to change the role reference, you need to delete that role binding, and again you create a role binding with a different role being referred there. But rules in the role you can modify, but a role binding reference you can't modify, okay, once it is created. So example, let's say like Balaji is a developer. For Balaji, I wanted to give the only limited permissions like that. Only limited permissions like that. Let's say like this, right? And I can create a role in whatever namespace. Let's say I'm creating in this namespace, or let's say you have something called for order management team. For order management team microservices, there is a team who is working on the order management microservice, and their Kubernetes resources they are trying to create in this namespace. You create a namespace, you define the resource quota in that namespace, and you create a role in this namespace for with these permissions. And Balaji is working as part of the team as a developer, so using the role binding you are linking these two. So using role binding, this is the name of the role binding, you can give anything. So here you are linking the role and subject. This subject can be user, or the subject can be group and group, or the subject can be service account with service account name. But these users and groups you can't create, I mean say users you can't create in Kubernetes. These users exist outside also. That is how you are binding. So now we are binding this role, whatever role we have created with this name, we are binding that role with subject, linking like that. So we are linking this role to this user. So now Balaji has a permissions to these resources in that namespace, in that whatever namespace you have created. Suppose even though Balaji has permissions to these resources, but he is trying to get the pods, he is trying to get the services, he is trying to update the services in kube system namespace or any other namespace, does the Kubernetes will allow? No. So this is how role and role binding works. This is how role and role binding works. This is how the role and role binding works. And here again there is a documentation here. Subject, what is subject? That subject here, this subject kind, the subject kind can be user, the subject kind can be group, or the subject kind can be service account, right? This can be group also. Suppose you have so many people, so many developers, maybe you can say group, you have a group name, development group or order management development group, something like that. And you can add users to the group. If you are adding users to the group, that is outside means independently from Kubernetes, right? You are adding the users to the group, and in that case if you are giving a permissions to the group, you are linking this role to the group. In this group, let's say 100 developers are there. Are they going to get same permissions whatever has been given for Kubernetes resources in this role? Yes. So that is how it works. Or it can be service account. It can be service account for programs. Suppose you have created a service account with a name called Jenkins, and for Jenkins you are attaching a role like this. Via Jenkins, to communicate with Kubernetes, again it can use kubectl, but instead of using a service, I mean instead of using user credentials, it can mention I am communicating with using this service account name. So if the service account has the permissions, then that program or application can create, update, delete like that. That is how service accounts will work. So here subject can be user, or subject can be a group, or subject can be a service account, right? Using that role binding you are doing this. So this is how role and role binding works. Before I try to explain about cluster role and cluster role binding, before I try to explain about cluster role and cluster role binding, let me tell you one more thing. Suppose a same role can be linked with multiple subjects also, like this. Maybe in same role binding also, you can do like this again, one more person or one more service account like that. Otherwise, this is like a list of subjects, right? You can do like this also, right? Maybe it can be subject, can be service account also. For this user this service account, or for this user this group, you are linking like this. Or maybe you can create one more cluster role binding if required. Separately also you wanted to do one more cluster role binding, different name you can give. And here same role can be linked with one more user or a group or a service account, like that also you can do. Understand what I'm saying? One role with the two different role bindings, binded with the two different users or a groups or a service accounts, like that also you can do. But before I explain about before I proceed here, let's understand what is cluster role and cluster role binding. Very important question in the interviews also. If they are expecting the people who has a good experience in Kubernetes administration, right? So what is difference between role and cluster role? So cluster role also work same as a role. Cluster role also work same as a role, but they are applied to the cluster as a whole. Cluster role works the same as a role, but they are applied to the cluster as a whole. These cluster roles are not bound to a specific namespace. Even though when you are creating a cluster role, you will tell the namespace name, under which namespace logically you wanted to create, but which doesn't mean the permissions are specific to that namespace. Using cluster role, I am giving a pods deployments permission. Even though I am creating a cluster role in some namespace, that permissions will be given, given in all other namespaces also. So cluster role works the same as a role, but they are applied to the cluster as a whole, not within specific namespace. Cluster roles are not bound to a specific namespace. Cluster role give access across more than one namespace or all namespaces again. After creating a cluster role again, you have to assign that cluster role to the subject, that can be user or a group of users or a service account, by creating cluster role binding. Cluster role cannot be binded with users or groups using role binding. Understand? Suppose you created a cluster role. If you wanted to bind that role to the subjects like users, group, service account, you have to use cluster role binding, not normal role binding. Suppose if you have created a role, suppose you have created a role, and if you wanted to bind that role, you have to use role binding. Suppose you have created a cluster role, you wanted to bind that cluster role, then you have to use cluster role binding. But cluster role also works as the same as a role, but they are applied to the cluster as a whole. These cluster roles are bound to a specific namespace. This cluster role gives access across more than one namespace or all namespaces. After creating a cluster role, again you can assign or bind that cluster role to the users or a groups by creating a cluster role binding. Cluster roles are cluster scoped. You can use cluster roles to control access to the different kind of resources that you can't do with roles again. Suppose you have so many resources. Let's say we have some resources that is common to all the namespaces, like kubectl, kubectl, API resources. There are so many, but some are namespace level, some are cluster level. Hyphen namespace. Let me show that. Namespace true. Suppose we have some resources in Kubernetes that is namespace specific. Suppose you wanted to, using role, you can give permissions to these type of resources. Using cluster role also you can give permissions to these type of resources. But if you are using, if you are granting permissions to these type of namespace resources using role, that permissions will be only in whatever namespace you are creating a role. Suppose you are using cluster roles to create permissions on these namespace resources also, but it will be across all namespaces. But we have some cluster level resources like nodes, persistent values, like this. You can't give permissions to the cluster level resources using role. Suppose you need to give permissions to the nodes, namespaces, persistent values. You can do using only cluster role. That is what you have to remember here. So once you create a cluster role again like this, right? Suppose here, suppose instead of role, I'm using kind cluster role, right? And using cluster role, I'm giving these permissions. And again, what I'm trying to do here, let's say here I'm creating a cluster role like this. This is the name of the role, and using cluster role binding, now this is not a normal role, this is a cluster role. So I have created a cluster role, and using cluster role binding, I am binding that cluster role to this user. Now, even though we are creating a this cluster role in this namespace, but these permissions not only in that namespace, these permissions in all namespaces. But again, for pods these permissions, apps these permissions, daemons it's, but for nodes and other things are still not, permissions is not given. Suppose if required, for nodes also you can give something like this. Nodes belongs to core API group. So nodes and namespaces belongs to that API group. For that one, you want only these permissions to the nodes and namespaces, you can give like that. Suppose for persistent volumes also read only permissions you wanted to give, you can say like this also. Understand this is a list, right? Suppose in another format also this can be represented. Suppose something like this, you may see sometimes like this also. Don't get confused, both are same. For nodes and like this also, in a YML representation also you can see same. Suppose sometimes you may see like this also, right? These permissions like that also, both are same only. I mean to say like in a YML format, this is also list or array. You guys already know YML. Both are same only, but understand this and this syntax also same. So whether you are defining this way or defining this way, both are same. But here, these for these resources, for these two resources that belongs to this API group, these permissions like that also you can give. So this is cluster role binding. Suppose you wanted to make few guys as an admins, right? So here you can create a cluster role. You can say API groups star, resources star, and verbs also star, right? All API groups, all resources, all permissions, and again you are binding this role. Meaningful names you can give. You can give role name as a admin role, cluster admin role, or admin role, whatever it can be, admin role. So this admin role name, right? You are binding with this Balaji now. Is Balaji becomes admin? Does Balaji can create, update, delete, get any resources in that Kubernetes cluster if this is how it is given? Yes. So that is how this cluster role binding, role and role binding works. I hope everyone clear theoretically. Now let's get into the implementation. Now let's imagine I am normal Balaji. Let's say I am a developer. And as a developers also, you may need access to the Kubernetes cluster in your local laptop or a desktop. Also, you can have a kubectl, a CLI, and you can interact with that Kubernetes cluster. That can be remote Kubernetes cluster. Remote means that is running somewhere. That can be in on-premise, somewhere it is running. That can be in cloud like AWS, Azure, GCP, it is running also. That doesn't matter. Suppose if you have a kubectl and you have that cluster details, you can interact with API server. But again, there is a networking concepts, guys. Suppose if you have a API server is hosted on private IPs. Suppose if you have a multi-master, or maybe you have a single master or a multi-master. Let's say you have a private endpoint to the API server. Let's say Even though you have a kubectl installed, even though you have a kubeconfig file where your cluster details is there, but if that is private endpoint, which means the API server don't have a public connection, public network, private only. In that case, do you think first of all, without that network, is the request will reach that API server first of all before it is authentication? Understand the networking concept also. First, the request has to reach API server. Then only it can perform authentication and authorization. First of all, if there is no network between the Kubernetes client or a Kubernetes user to the Kubernetes cluster, do you think first of all, it request will reach that API server first of all? No. So in most of the real clusters, do you think that API server will be exposed to the public or internet like that? No, it will be private endpoint. But I was explaining this EKS cluster. When I created a EKS cluster also, if you created a self-managed Kubernetes cluster also, when you are executing kubedia init, you can give endpoint IP. If required, you can host Kubernetes with a shared endpoint also, multi-master. That endpoint IP can be private IP, private load balancer also, or you can have a public load balancer with public IP initiated. But when I created a EKS cluster, that multiple masters will be there, that will be completely owned and managed by AWS. But they are telling whether you wanted to have a private endpoint or public endpoint or private and public endpoint like that. So when I created a EKS cluster, right, this is fully managed Kubernetes cluster. As per that options, it is going to set up the cluster and connectivity. But in case of self-managed, you have a control everything. You can initiate the Kubernetes cluster with a shared endpoint. We discussed this if you remember, right? And that can be private IP, private shared endpoint, or public IP with public endpoint like that. But when I created this EKS cluster in auto mode, also, that time we have selected something called public and private endpoint. You can see API server endpoint, public and private. So because I have selected this, even though I am not part of the same network via VPN or VPN, site to site VPN or client server VPN, this we have discussed in a AWS sessions. What is network, what is private network, what is public network? If it is a private network, how you are part of another network can communicate with that private instances in other private network via client server VPN, site to site VPN. We have discussed all those things, right? Now I have created this with the public and private endpoint access. So even though my local laptop, I am not part of any VPN, right? I'm not part of any VPN, but still, since I have created a public and private endpoint, so I can reach my API server from my personal laptop or a desktop. But in real time, do you think are we going to have these type of endpoints given? But again, understand, even though you have given public and private endpoint, at least the request will reach till API server. But in that Kubernetes, there is no permissions for that user, again. He is not part of that identity. He is not part of that identity center from where API server is authenticating. And he is not given permissions and he is not part of that identity center. That user is unknown user. Again, even though there is a network, does API server will allow to that request coming to that API server for creating, getting, updating, deleting, something like that? Understand. There is a multiple levels of security, network security, Kubernetes security, like that. And again, AWS security. Let's understand first of all, if that user EKS is one AWS service. EKS is first of all one AWS service. Before it is a Kubernetes, it is AWS. So if that user don't have a permissions on EKS, AWS, EKS is different, Kubernetes is different. EKS is a Kubernetes only, but EKS is first one AWS service like EC2. Suppose that user don't have a permissions on EKS, do you think that do you think that user will be able to get a kubeconfig file of that EKS first of all? Will be able to get API server details first of all, like that. So everything is related. You have to understand the things, right? So this is what we have discussed already so many things. AWS IAM, what is AWS IAM, how we can use AWS IAM. I already told so many times in our Rushi Technologies YouTube channel. There is a detailed video. There is a detailed video here. AWS IAM and CLI, how important it is. In AWS, this EKC is also an AWS service. First of all, even though you have a permissions in Kubernetes, if that user don't have a permissions on AWS, he can't get that kubeconfig file first of all, right? So like that. So here we have discussed what is IAM, how IAM works, right? In a detailed video, more than 2 hours. I hope you guys went through this video, right? Now let's come back. So when we are creating an EKS cluster, you can configure. You can configure these type of things, like you can go and manage endpoint access also. Later also you can change private, like that. So this cluster endpoint only accessible through your VPC, and no traffic also will stay within your VPC, like that. But if I do like this, unless until the users, Kubernetes users or developers or DevOps guys has a private connectivity with this network, in whatever network there is a VPE case created via maybe site-to-site VPN, client-server VPN, like that also. You can establish the private connectivity, then only they can reach that API server first of all. But for now, let it be public and private. While creating a cluster with auto mode also, right? Suppose you are creating a EKS cluster in auto mode or a standard mode also, you can see this. Suppose by default, by default they are choosing this cluster endpoint access. By default, they are choosing this cluster endpoint access. You can see here public and private, like that. Cluster endpoint access, public and private, yes. But if you don't want this way, you can go with custom configuration again with auto mode. We discussed about what is EKS auto mode, what is standard mode in previous sessions. So you can go with this. Here you have a you can modify again, like how we can control how IAM principles are can access this cluster, how we can grant permissions. Here again, EKS is integrated with IAM, and again, whether you wanted to manage the permissions to that use IAM users via EKS APIs, or there is something called config map. Now this config map is not required because there is a different way EKS auto mode is allowing to add the user, give the permissions to the cluster. But here you can go next. Here you can select cluster name, like that. You can select that private you need, like that also you can do that. But anyhow, this is cluster creation. We already have a cluster with that public and private endpoint access. Now let's say you are a normal developer, you are a DevOps normal developer. Let's say my local laptop, whether you are using a Windows laptop or a desktop, whether you are using a MacBook. In my local laptop, this is my personal system. That personal system, in real time, it is an office provided system. Office provided system, right? So here, this is your system, not any other system or a server. So from here also I can interact with my Kubernetes clusters. That can be dev cluster, production cluster, staging cluster, if I have a permissions again, right? Now let's say here, first of all, what you need, we discussed in the Kubernetes architecture. So what under tools we need in order to interact with any API, and means any Kubernetes cluster, that can be local, single node, multi-node, self-managed or fully managed. Here you need a kubectl, Kubernetes CLI, kubectl or a Kubernetes CLI, right? So let's say I will install kubectl. Can we install kubectl locally? That can be in Windows laptops or desktops, or that can be MacBooks. Otherwise, you are using Linux desktops given by your office, like Ubuntu desktops, like that also. Yes. So you can install kubectl any system. So here, let me tell you, install kubectl. Install kubectl. So you can install kubectl, and Windows also you can install, Mac also you can install if required. Suppose you are using Windows laptop or a desktop, simply you can go and download this. You can go and download this kubectl binary, right? You can go and download. You can go to this, right? You can download options they are telling, right? You can download the latest one for Windows, right? Latest version. So you can download for most of the time AMD processor only. You can download here. You can download kubectl, kubectl.exe file. You can see like this. You can see, you can click on this, it will download. It will download, right? But here they are telling, either you can directly do like this also. Maybe you can open this. This is what they are telling. You can just, instead of curl, or maybe you can execute in your Windows laptop command prompt or a PowerShell also. Otherwise you can directly take this URL. You can go to your browser, paste this, it will download this type of exe file, executable file. So once you download that executable file, right, what you can do there, right? What you can do there, once you execute, once you have that executable file, later you have to add that to the path, environment variable path. In Windows, right, path. So maybe you have downloaded this exe file. You take this exe file and keep in some folder, and take the path of the folder and add that to the environment variable called path, Windows environment variables. I hope you guys already know how to do that, because we have discussed all these things in the basics only, fundamentals. Without, even though you downloaded that exe file, if that into whatever folder you have downloaded, or maybe in whatever folder you are maintaining that, if you don't add that path where you have that kubectl exe file to the path environment variable, if you execute kubectl commands in your Windows command prompt or PowerShell also, it will say kubectl not found, kubectl not found, like that. So you can do that. Suppose if you are using MacBook, also you can download kubectl. Suppose via homebrew is a package manager. So you can execute something like this: brew install kubectl, or brew install Kubernetes CLI, like that also you can do. I am using a MacBook, right? So I can execute like this, using this. It is going to download that kubectl binaries for Mac, and it will install. Basically, this is like a package manager for Mac. It is downloading and installing kubectl here in my local laptop. That can be your office laptop given by your office. That can be whatever it can be. Now I have a kubectl installed, kubectl version -client. Now you can see this version of the kubectl is there. But if you have only kubectl and there is no kubeconfig file, and where it is pointing to the API server address, without that, if you try to execute kubectl commands, does kubectl knows to which API server, to which cluster? Basically, API server is nothing but a cluster. To which cluster it has to talk to first? No. So if I execute kubectl get nodes, it is saying, it is thinking that API server is there on this local host 8080 port, like that. No, right? So my cluster is somewhere else. So now here I have to get the kubeconfig file. Suppose this kubeconfig files will be given by admins. Otherwise, if it is a self-managed Kubernetes cluster, admins may give kubeconfig files and details. Otherwise, there is a tool. Maybe there is a tool, you can generate the kubeconfig file from that tool. Or suppose if it is a fully managed Kubernetes clusters like EKS or AKS or GKE, then how I can get the kubeconfig file here? You can use CLIs, AWS CLI. Understand, first of all, AWS concepts also comes into the picture. Now here, let's say here, can I install AWS CLI in my local Windows laptop, MacBooks also, if required? Yes. So here in this video, already it is there. like how to install AWS CLI in Windows laptops or desktops or MacBooks also, and how you can give AWS permissions also, like that here I have explained. But let's say I can install AWS CLI in Mac, Windows also if required. Install AWS CLI. For Windows also you can install, Mac also you can install, like that. So here use this CLI version 2, like that. So here you can go and download and install installing, right? AWS CLI in Mac also you can install, Windows also you can install. In case of Windows, it is directly MSI file. MSI file means you can download, double click on next, 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 like that. It will install and you can use it, right? Here, suppose if it is Mac, I can install via Homebrew or as a package like this Mac packages, PKG files. Again, that is based on here Mac package. You can take it and you can double click on these packages in local MacBook. Let me just follow next, next, next. It is asking my local laptop admin password for installation of software in my Mac. Now let's say we have done this AWS CLI installation. Now if I go open any command prompt in my laptop, if I execute AWS hyphen version, I should see AWS which version of the AWS is installed. Now we have a little bit of AWS concepts also here. Now AWS administrators also comes into picture here. First of all, EKS is a AWS service. So if you don't have at least some permissions, read permissions on EKS read permissions, do you think you will be able to get the kubeconfig file of EKS cluster? No. So I am talking about EKS permission, right? Then who can give that AWS permissions? AWS administrators. So AWS administrators, right? EKS is first AWS service. Suppose I have just installed AWS here, but I have not configured any access key or secret key, my credentials here. AWS STS get caller identity, if you see. So we don't have anything. So here I can configure. Let's say now we already discussed all these things in AWS. So I don't want to waste much time. Let's say this is already AWS admin account. So this is a AWS admin account or a root account, right? Typically in real time, no one will directly create a root, resources using root. This root user initially creates some admins. That admins will create permissions to other users, and admins can create a resources and other permissions to other users, like that. Anyhow, fine. First, let's say I will go to IAM. I will create one user called Balaji. Imagine you are a Kubernetes admin. So you can create a users. But if this IAM is already integrated with Identity Center, you no need to create a users here. You can just assign the AWS permissions to that external identity users also here. But as of now, we don't have any external identity. Let me create a user here itself. I'm creating a user called Balaji, right? I don't want to give console. This we already discussed. I don't want to give console permissions for now, programmatic access, but only user is there, and without any Kubernetes permissions, without any Kubernetes permission, without any Kubernetes permissions. Then I would say not Kubernetes, sorry, without any AWS permission. This is a without any AWS permissions. If there is a user, right? Even though let me generate the access keys and secret key as of now, this user directly, this is the user. Let me go to this user, IAM user. Let me go to this. Let me go to security credentials here itself. Imagine I am a Balaji. I logged into my AWS. I logged into my AWS using that username and password, but as of now I have not given that console access, like that. For now, let's fine. But I recommend you to go through that AWS IAM video so that you can understand IAM concepts also in a detailed way. For now, I am focusing on Kubernetes administration. Let's say click on next, create access key, secret key. Now this is access key of Balaji. Let's say I will configure, but without configuring, if I try to say AWS EKS update kubeconfig, this command we already discussed, EKS update kubeconfig, hyphen name, cluster name, and a region, hyphen region. I have my cluster in this region. Which region? I think I have created US West 1, North California. So US West 1. If you see, it will say you don't have any credentials like that. Now I will configure AWS configure. AWS configure. I will give access key, secret key. This access key, this secret key. This is normal Balaji user access key, secret key. Now region also I will say region US West 1, and output format table. Sorry, let me reconfigure. Press enter, secret key. Default region I will say US West 1, and output format table format or JSON format, whatever you would like to tell, you can tell. Now we have configured, but this Balaji is going to communicate with AWS to get the EKS, but Balaji don't have a EKS permission. If you see, AWS is throwing error saying that user Balaji don't have this permission, EKS describe cluster permissions on this cluster. So in order to get the kubeconfig file also, this user should have these permissions, describe cluster permission. Like this permissions are not there. So if required, what you can do, right? We created a user. We created a user like this, right? For that user, you can attach some policy, at least these permissions, list cluster permissions, describe cluster permissions, like that. But I will tell you what is this Kubernetes API. So even EKS simplified RBAC concepts also. So EKS even simplified the RBAC concepts again, right? So there are multiple ways again. If you are using EKS, there are other ways also. You can give Kubernetes permissions using Kubernetes APIs, EKS APIs, Kubernetes APIs, like that. So I will tell you about this. So now there are multiple ways you can give the permissions without RBAC also, without creating this type of role binding in Kubernetes also. You can give permissions to the Kubernetes users if you are using EKS. That is because there is a built-in access policy in EKS. There is a built-in access policies already. AWS, this Kubernetes permissions, already there is a predefined rules, predefined role bindings are already created. When you are granting permissions, you can select whether you need read-only permissions, admin permissions, like that in that EKS for Kubernetes. For that Kubernetes in that Kubernetes in the EKS cluster, without you create a role, that cluster role or a normal role or a cluster role, already there is a, they have simplified already. You have some permissions, you just create you give the access to that user, and give whether developer permissions or admin permissions, like that. You can go with this option also. Otherwise there is a one more option, you wanted to go via normal RBAC also, but this is also RBAC only. But EKS, AWS simplified of giving a permissions to the Kubernetes resources. This is if you wanted to customize more, right? Specific permissions only. Here you have only limited, like admin permission, read edit permission, view permissions, like that. But I don't want to give admin permissions, edit permissions for all the resources, like that. Again, you can go in a normal mode also. I will show both options. First, let me tell you, first of all, I have a, if without this permissions I can't get the kubeconfig file. This is AWS permissions, not Kubernetes permission. But even though you have given AWS permissions, without these Kubernetes permissions, again authentication may happen, but authorization, do you think it will happen like that? No. So now let me show step by step. So I have configured a user, but I have not given permissions. So you can go and create some custom policy. You can go and create some custom policy. You can go and create some custom policy with these permissions. Let's say I will go and go to IAM. This is a AWS administrator job. Let me go to IAM policies, not Kubernetes policies, IAM policy. Here I will create some custom policy. So for which service you wanted to create a permission, I wanted to give permissions to EKS, but I don't want to give all permissions on EKS. Let's imagine this is AWS permissions. Suppose you have given all permissions like that, is that AWS user can delete that EKS cluster itself? First of all, forget about deleting the resources in the cluster. First of all, that cluster itself can be deleted with all permissions. Yes. So it is not recommended. This is cluster per EKS permission. So here you can give limited, like list permissions, that list clusters. This list cluster, you can select only if required list clusters, at least minimal permission, and a describe cluster. Here there is something called describe cluster. At least these two also required. Otherwise, both list and read both again like this also you can do that. At least minimal list cluster, describe cluster. Suppose if I select this option, they can describe or they can see what add-ons is installed and how many node groups are there in that clusters, like that also if required. This is AWS permissions, okay, not Kubernetes permission. Suppose if required, you can select here itself all a list or all read like that, or maybe only at least these two is required. At least these two is required, right? List clusters and a describe cluster like that. Again, list clusters, describe clusters like that. At least this is required. This is required. This, at least these permissions is required. Minimal permissions. Minimal permissions is required. You can create a custom role. You can create a custom role like this with all a list like that also. Like that. At least. Suppose using Kubernetes EKS APIs, using Kubernetes EKS APIs, using Kubernetes EKS APIs itself, using Kubernetes EKS APIs, right? You wanted to give permissions to that people for whatever user you wanted to give Kubernetes permissions using Kubernetes APIs, right? Instead of RBAC, again this is also RBAC only, but instead of you create a role binding for these users, the the EKS itself will create. But if you wanted to control the Kubernetes permissions, using that EKS API, then you have to select this one also, this permission also, access to the Kubernetes API. So here there are, there are two ways you can grant access to the Kubernetes for role users. One is you go and create a role binding, and so that they can access. Otherwise, instead of you create a role and role binding, AWS EKS even simplified the process now in this auto mode. In this auto mode, they have even simplified that one also. So instead of you go and create a role binding, EKS can do that also. So I will show both options. I will show both options. Let's say for now, this is required. This is required if you are trying to give Kubernetes permissions in EKS clusters with this approach. So built-in access policies, right? Built-in access policies, you can do that, right? So if you want to go with this option, this permission is also required for that user. Suppose if you don't want to go with this way of giving a user's permission, then using a RBAC you wanted to go, then you don't you no need to give this. Then you have to manually create a cluster role or a role like this, and you have to give that user. That user, you can create a role binding and bind that user here, so that based on what you have defined, based on that permissions will come. This is another option. But if you want go with this option of RBAC in EKS, you that don't need this access, this permission. Otherwise, this is also required. I will show both. Don't worry, I will show both. Now let's say this is I am selecting. Click on all EKS clusters. This permission are specific like that. For all EKS clusters, only these limited permissions I have selected. If required, you can select both list and read all also, but I am at least selecting minimal like that. Otherwise, you can select this one and this one, but list only. Don't give write. Write means they can delete the cluster also. That is not recommended for development team. Right? Now, for all clusters or maybe specific cluster also you can do that. Right? No resources specified. So here no resources specified. Specific resources are all resources. Click on next. Okay, all resources. Policy name I will say EKS read only. This is EKS permission, not AWS permission. This is not Kubernetes permission. EKS read only access. This is the policy name. EKS read only access policy, right? Like that. This policy I will attach to that AWS user. This is AWS concept because EKS is a AWS service first. So here I will attach this policy to that user. Maybe directly to this user also I can attach that policy, or you can add that user to the group. AWS concept here. Add permissions, attach policies, whatever I have created, customer managed policy, this policy I will attach. Now that Balaji will have a permissions to get the EKS first of all. Let's say AWS EKS list cluster, because we have given permissions to list clusters, describe cluster like that. AWS EKS list cluster. He can see how many EKS clusters are there. List clusters. You can see one cluster is there. Similarly, but he don't have a permission. Suppose accidentally or intentionally, if we say delete cluster via AWS CLI or GUI also, if we say, it will throw error. It will throw error. Delete. Let's say delete cluster hyphen name cluster name. Let's say it will throw error. Boss, you don't have a permission. But suppose these type of audits also can be tracked, guys, in AWS. Okay. Anyhow, that is different concept. We already discussed all those things. For now, leave it. Now I will get the kubeconfig file of this cluster. But we have a kubeconfig file. This kubeconfig file has a cluster details. But anywhere is this user is integrated with this cluster like that for authentication itself? No, there are some ways to do that. Now let's say we have a kubeconfig file. In that kubeconfig file, there is a cluster details like that, and it is token based authentication. So whenever we are executing any kubectl command, request will go to this server, and using the token of this current user. But let me execute kubectl get nodes, kubectl get pods. It will throw some error. So here we need to integrate this user. You must log in like that. Authentication itself is not happening. So here, how we can give that Kubernetes permissions, authentication and authorization here. First, authentication. Right here, go to your EKS cluster. For that Balaji, right? Go to this EKS cluster. Here there is something called access. Earlier they used to have a config map. In that config map, we used to link that IAM user with that cluster like that for authentication. But for now, there is a little changes also. You can still use that config map approach or API approach. Here, go to this cluster, go to this access. You have to create a entries for IAM entries to authenticate for that IAM users with this cluster. So here you can click on create. Go to this cluster, go to this access. You can create like that, access entries, create like that. Here, So here, for which IAM user you wanted to give permissions, I mean, it's authentication, right? I will select this Balaji, right? So here type, you just select a standard type, right? Here just select a standard, and here leave it these defaults. If required, you can just leave this as is, right? And here click on next. Here here itself you can see it is asking what Kubernetes permissions you wanted to give for that user, whether you wanted to give cluster permissions or namespace permissions. And again here, these are like a Kubernetes permissions. Here you can see some permissions: list only, read only, like that. List only, read only, like that also. You can here select permissions. Here if you see, without you create a RBAC, there is a way here. That is what I am trying to explain here. So here you can see in this option, built-in access, you are you went to this clusters, you added that access entry. For that you are selecting which permission. So here if required, you can select like this: edit policy, Amazon e-case admin policy, Amazon e-case read policy, like that. So here you can see edit policy, view policy, Amazon e-case view policy. View policy means like a read only permissions to the Kubernetes resources. Internally they are going to create a role bindings in the background. In that, instead of you create this e-case APIs will internally create a role binding for that user, right? With this permissions, whether cluster or namespace. If it is a namespace only, you wanted to view permissions, or you wanted to give edit permissions. Edit means create, update, delete, like that. Or admin permissions. At namespace level you can make admin, or cluster level you can make admin by selecting cluster admin or namespace admin, right? Otherwise edit policy on cluster or namespace, or view policy on cluster namespace, like that. You can see some Kubernetes permissions here. This is a specific to e-case, but that RBAC, internally RBAC only they are using. But instead of you create that role binding for that user, AWS itself will create these rules in the cluster. If you don't want to go this way, right? If you don't want to go this way, there is other ways to do that. Other ways you can go and you can go and create directly, right? Instead of you create this way, you can go and create as a Kubernetes admin that role binding, like that also. For now, let's say here e-case cluster view policy only for particular namespace. Let's say I have a namespace called test-ns. So for like that, I'm creating policy also for this user, right? If you see namespace, I think I have missed it. Select this e-case view policy for this namespace, right? Add that policy. I forgot to click on that add that policy, like that. So I have added. Click on next. Now this user will authenticate, and as per this permissions in this namespace, he has this Kubernetes permissions. This is a e-case way of doing also, but in the background role binding will be created, but instead of we create, AWS will create in the background, like that. now let's say now let's say this is Balaji. Now I have configured, this is my local laptop. Let's execute kubectl get pods -n test namespace, like that. -n test namespace, like that. Now you see Balaji got a permissions on this namespace as per that whatever we have created as a AWS admin or a Kubernetes admin this way. But you may have a doubt, sir, we have not created a role. You have not created a role binding. But how come Balaji is getting this? Because that is internally done by AWS e-case using APIs, Kubernetes APIs. This is one way of doing. Even this is simplified. AWS simplified of creating a role binding, or a cluster role binding using this approach. But here you have to have a lot of customization, right? In that case, still the Kubernetes admin can still create a role bindings, and they can bind also. Then now let's say pods permissions are there, but let's say kubectl get namespace. But what it is saying when I am trying to say give me namespace like that, it is saying you don't have permissions. Namespace permissions you don't have. Namespace permissions you don't have. Similarly, let's say we have a kubectl get all -n this namespace, right? It will give you details like this. But let's say view only. Let's say in other namespaces, if he is trying to get in other namespaces, if he is trying to get, it is saying you don't have a permissions on this namespace, because when I created this way Kubernetes permissions, what I have told, if you see view policy only in this namespace, internally AWS created one role for all resources in that namespace, and that is linked with this user automatically. Instead of we create, AWS has done that way, but it is not allowing in other namespace, right? Other namespaces, right? So here you can do like this also: kubectl auth who am I, kubectl auth hyphen help. So you say kubectl auth who am I, right? If you execute like this also, it will show who am I. So you are connecting as this user, you are connecting with this user like that. You are communicating with your Kubernetes cluster using this user like that. And what permissions I have also, you can say kubectl auth can I get node. It will say no. It is saying no, because I don't have a permissions to get the nodes. Can I get pods in this namespace? Yes, because that is how the permissions has been given. But in other namespace, can I get? No, no, no. Let's say kubectl, can I get or create role in Kubernetes? No. In that namespace also, let's see, no, no. But can I get role like this? What permissions you can also, you can verify like this also, this way. You don't have a role permissions, but only other permissions are there. Workload permissions are there, admin permissions. For role also it is not there like that. So this is how internal it is doing. Suppose for this guy you wanted to give admin permissions, again what you can do in this is also RBAC only, but AWS is creating in the background that permissions like that. Suppose you can go to this, you can go to this entry, this particular user entry. Here if required, you can add additional policies also. Let's say you wanted to give, let's say, view policy or edit policy or admin policy like that. Let's say view policy for complete cluster also, right? Add policy, one more policy we have added to the same user, right? I mean, say one more policy like you have added, let's say like that. Now as per that policies, right, in the background, in the background we have given for all namespaces like that. Now let's say kubectl get all in kube system namespace, right? In kube system namespace. Now because I have given cluster level, so kube system is also one namespace. Similarly test namespace like that. Permissions, right? So you can see in the background it is RBAC only, but who is creating permissions on this Kubernetes for that users? Who is linking that permissions on that role binding or that role binding, cluster role binding? AWS case is doing using AWS APIs in the background. This is simplified version of RBAC. But if you wanted to control, because I may wanted to give, let's say here I have a permissions, this guy has a permissions on daemon sets or a stateful sets or a secrets. Let's say this guy permissions on a secrets. This guy permission has on a secrets, right? Secrets, like that. Otherwise this guy don't have a permissions on secrets for some reason. This that whatever way I have given this view, I think view policy, there is no permissions on secrets. At least read only permissions also not there. But here can we customize more? Here more customization can be done here, like whatever they are only giving, they are like that. But if required for some reason I wanted to give secrets permissions to this user, can I go and create my own RBAC within the cluster as a Kubernetes admin again? Like that, yes. So you can do that also if required. Now if you see kubectl get nodes, he don't have a nodes permissions, he don't have a namespace permissions, like that. Namespace permissions are there, nodes permissions are not there. But let's say he wanted to see some nodes, he wanted to see some secrets. In that case, as a Kubernetes admin, now understand this is my system here already as a whatever user. This is not my local laptop. So as a whatever user, I have created a cluster. That user credentials I have configured here. That user credentials, that by default that has a admin permission, that user, this is, you think this is a Kubernetes admin, or you also have admin permissions, maybe as a you also have a admin permission. Let's say here this is my system where I have admin credentials, like admin credentials, right? Basically as this user, this user we have already authenticated. This is a user who already created a cluster. So this guy has a full permissions in the cluster, like he can create roles, role bindings also. He can create roles, role bindings also, because if you see here also, cluster, this access entities, you can see this root, right? The way I have Balaji user, that with this permission, this is the user who created a cluster. By default that user will have a cluster admin permissions. This is Kubernetes admin permission. Because of that this guy, imagine as a whatever user you have created, by default they will have a full permissions. That's why they can see nodes, that's why they can configure a storage classes, that's why they can do like that. Now this Kubernetes admin can give whatever custom permissions required for Balaji if required. Yes, like this way. So you can create a role bindings, like that also. Let's say I will create a role or a role binding, like this. I can create a role binding like this. I can create a role binding like this. Otherwise I can create cluster role binding also. Let's say I wanted to give some additional permissions also. One user can binded with multiple roles also. Again, one user can be binded with multiple cluster roles or roles also in the background, right? Now let's say this guy has a permissions to see the roles are a cluster role hyphen n, all namespaces also you can do. So this guy has a permissions to see the cluster role. This guy has a permissions to see the cluster role again. Cluster roles or normal roles also, like that he can do that. Like that he can see roles, he can edit roles, he can delete roles, bindings also he can do. Cluster role binding, cluster role binding, like that. Also bindings also you can do, you can see like that, right? So this guy has a permissions. This guy can create a custom also with whatever. Let's say I will take a YML file. I will take a YML file. I will create a cluster role as an admin. Now let's say cluster role. Okay, it is not generating, auto generating. Let me do that. Fine. So here I will create a cluster role or a normal role. It's up to you. Let's say that this is manifest. Here, let's say I wanted to give permissions to the nodes, right? Let's see, maybe Balaji. Let's say Balaji is having a permissions to VP's the PV persistent value. No. And again, Balaji has a, I think, read-only permissions again. Balaji has a read-only permissions to the pods, nodes like that. Let's say if he's trying to delete, I think it is not going to allow, because I think we have given view policy, right? Not edit policy. Kubectl delete deployment. Let's say deployment name, like this. Now, if I am doing this way, also it is saying you don't have a permission. Let's say you can give edit policy also, but you can go and assign to this entities policies like this again. You can add additional, like you can select a view policy, admin policy like that again, for namespace level, cluster level like that also you can do. But you wanted more granular level control also, then you can go and do this way. So you can create some role name can be whatever, right? Like role name can be nodes read only, something, anything, like a read only role, cluster role, like that. Maybe for here nodes, for nodes and persistent values, you have to give full, guys, not like that completely. Kubectl API resources, that persistent values also, that persistent values also belongs to v1 API group, right? So you can say full, you have to give, not PV like that short forms. You have to give full. Suppose for this person you wanted to give at least read only for persistent values, at least to see that, like this. And again here, instead of all, I can say list watch, like that. So you can give whatever, like list watch, read, like that. This way you can do that. This way whatever you need, like list watch for these like that also you can set, like this list watch read permissions, like that get list watch, like a get. Now on these two resources here, in case of IAM you have to give that complete. This can be created in any namespace, that doesn't matter. Now I have only this namespace. So here it is, in case of AWS IAM user, you have to give not only like Balaji, like that complete ARN, you have to give. So this is the user ARN, right? You can give completely like this. Now we are linking this user with this role, this cluster role. You are linking, let's say role reference is missing. Let's say you are linking like this, that role reference, this is the name of the role, this is the name of the role, like that you can link, right? Because these are like a cluster level resources. Now only for this you can give, or any other things also you can give like that. Let's say here, let me have it in a YML. This is separate, this is separate. So like this we are creating a cluster role, and we are, this is a not normal role again, this is again cluster role. This is the name of the role. Using that role you are giving these permission. So you can do like this also here. But Balaji cannot do, because Balaji don't have a permissions on this. Only the admin who has already permissions on this role and permissions on these Kubernetes resources, they can do that. Now Balaji cannot create, edit, delete these type of rules. Okay. Now let's do this. kubectl apply -f cluster role. Now this is done. Now let's come back as a Balaji here. This is my local laptop. Last time when I am saying kubectl get nodes, it has thrown error saying that you don't have a permission. Now let's say kubectl get nodes. At least read only permissions should be there. Now you can see kubectl get pv like this. Now if you wanted to make storage class is not there, you can if required you can give storage class also permissions like that, other permissions like that. Suppose if you want to make a customized control also, you can do this way. But if you are using self-managed Kubernetes cluster, these type of things you can do. You can only do create role binding like that. But since we are using AWS, right, AWS is doing some kind of a heavy lifting from us. So here whatever you do this way, both you can use together, both you can use together, right? So this is like you are linking that user to the cluster, and then you are defining a permissions. You can link that user with some permissions here, but additional permissions, customized permissions, you can give in a normal way also. But RBAC only internally using. But this is internally, AWS is internally creating a required role, cluster role, based on that policy that we are selecting, Kubernetes policies that we are selecting as per this user, like that. So understand RBAC concept, as well as the EKS feature, additional features in the there in the EKS for managing permissions in Kubernetes also, they are giving control. So understand guys, whatever has been explained, it's a very important session. I tried to explain in a simple ways, and again I have explained all the use cases scenarios in this, so that you should be able to understand, you should be able to explain, you should be able to use it and work it in any applications or a project. Is everyone clear whatever has been explained today's session? RBAC. So try to practice whatever has been discussed. Try to practice whatever has been discussed, right? From here, I'll continue in the next session, guys. Okay. Thank you. Have a great weekend. And I really appreciate your time and effort also, taking the time on weekend and attending the classes. So if you have this type of commitment, if you have this type of interest, right, nothing is impossible, everything is possible. As I already said, the mindset is very important. You should have that commitment and mindset towards learning something new and exploring something new, so that you can compete easily with any person who already have an experience. I can challenge, even though some people are working on a cloud like AWS or Kubernetes for last 5 6 years also, not everyone will get opportunity on every corner of the DevOps, right? Even though they may have a Kubernetes, they might be using. Some users still don't know these concepts because they have not worked on that. Maybe someone else worked on that. But what is the advantage of these trainings and with instructions, right? So you will get an opportunity to understand every corner of the tool technology. So later it will be you, whether you work on it, don't work, that is secondary in the projects, but you have a complete idea on that, right? So that is what I am trying to also explain here. Thank you. That's it for today.